Hello students, how are you? कैसे हो आप लोग? मेरी वीडियो स्टार्ट नहीं हुई क्या? अरे ये आई हैव स्टार्टेड द लाइव स्ट्रीमिंग। हाँ, मैग्नेटिज्म पर। चलो, हेलो कुसुमा जी, और यू कैसे आप बच्चे? आइए, स्वागत है आपका, है ना, मैग्नेटिज्म की क्लास पर। ठीक है, तो आज का सेशन हम स्टार्ट करते हैं। हाँ भाई, तो हम मैग्नेटिज्म स्टार्ट करने वाले हैं। उससे पहले कुछ इलेक्ट्रिसिटी के इंपॉर्टेंट क्वेश्चन कर लेते हैं। मैं आपको यहां से करवाने वाला था क्वेश्चन नंबर 16 से। क्या 16 का आंसर आप कैलकुलेट कर सकते हो? आपके पास ये सर्किट डायग्राम है। आपके पास ये सर्किट डायग्राम है। आपको बताना है कितना करंट एम्पियर, कितना करंट फ्लो कर रहा है, कितना करंट फ्लो कर रहा है। तो ए ऑप्शन आप देख सकते हो, 0.1 एम्पियर, 0.3 एम्पियर, 0.6 एम्पियर, नन ऑफ द अबव। कर सकते हैं आप लोग ये क्वेश्चन, तो ट्राई करिए, नहीं तो may God bless everyone, है ना भाई? If you can do these type of questions, then try them. Otherwise, no problem in this, है ना? Uh, I'm saying this infinity time. I'm good. Okay. Good. Anaswara ji, Kusuma ji. आइए कुसुमा जी, क्वेश्चन नंबर 16 देखिए आप लोग सारे बच्चे। क्वेश्चन नंबर 16 देखिए फटाफट से। IIEU। हाँ भाई, जल्दी करिए। क्वेश्चन नंबर कौन सा है ये? 16 है। हम्म क्वेश्चन नंबर 16 आप देख सकते हैं, बहुत इजी क्वेश्चन है। अगर आप लोग के लिए क्वेश्चन करूं मैं, है ना, तो आप देख सकते हैं ये और ये दोनों किस में है, जल्दी बताइए। सर, दे आर इन सीरीज। ठीक है, so this circuit can be transformed it into the shape of like this. So now we got to know the value of these resistances: 60 ohm, 15 plus 5, 20 ohm, and 10 ohm. Now we can see that these resistors are connected in parallel. So for parallel equivalent circuit, let us apply the formula 1 upon 60 plus 1 upon 20 plus 1 upon 10. So the LCM would be 61 plus 6, sorry, 10 6 plus 3. So this is 1 upon R equivalent, and the value of R equivalent will be 60 upon 10. This means 6 ohm. The value of R equivalent of this given circuit is 6 ohm. So we have calculated the net equivalent resistance across this circuit, which is about 6 ohms. Now we need to calculate the I current in amperes. This is a very smart question, because generally we use Ohm's law and we are given these type of questions to solve in our competitive examination as well as board examination. And we also know sort of question that how to solve them or how to rectify our mistakes, because we have practiced many type of questions like this, but this one is somewhere unique than others. As you can see, these all resistors give the equivalent resistance of 6 ohm. So while calculating the current through 60 ampere, while calculating the current through 60 ohm resistor will be equals to, as they are in parallel, then potential difference will be equal for each and every branch upon R equivalent. Okay, so let us try to resolve this question. So we have we need to calculate I. Okay, question number 16. In the lower arm we have calculated this. Okay. So षड्यंत्र चलाया गया था, अरे वाह, क्या मस्त डायलॉग मारे हो तुम है. So let us move on to the question number 17. As you can see this diagram, try to solve this question, है ना. Question number 17 is somewhere very much easy than the previous one. Here we need to calculate the value of capital R, and we are given with a circuit in which capital R is the resistance whose value is what we need to find, and current flowing into this circuit is 0.25 ampere, and potential difference provided by the battery is 12 volts. There are three resistors other than capital R that are 10 ohm, 20 ohm, 60 ohm. So you need to calculate the value of capital R. So you are given with the potential difference 12 volts. You are given with the net current which is 0.25 ampere. You are given with the these three resistors. Now try to calculate or evaluate that whether they are connected in parallel or in series. They are connected in parallel or in series. We can easily recognize this question. As we can see, these three resistors are joined with each other end to end. Means this 10 ohm resistor is connected to the 20 ohm resistor on both ends directly. Similarly, 20 ohm and 60 ohm resistor are connected to each other directly by their endpoints. Okay, got it. And the last one, 10 ohm and 60 ohm are also connected directly to their respective ends. So Kusuma, we can see that these 10 ohm, 20 ohm and 60 ohm are in parallel. Yes, sir. So R equivalent of this whole square will be is equals to 1 upon 10 plus 1 upon 20 plus 1 upon 60. Is everyone getting my point? So R equivalent in this square would be 6 ohm. Got it, sir. Why I have put this value directly? Because we have calculated the R equivalent, which was equals to 6 ohm in the previous question, and in this question also R equivalent is equals to 6 ohm, as the calculation is similar like the previous one. So R equivalent is equals to 6 ohm. Now we can see that this R and this whole R dash means R equivalent of this square are connected in series. Yes, sir. Why not? Because their one point is directly connected, but while joining the other point of these resistors, this battery comes in between, which creates potential difference of 12 volt in the circuit or any two random points in the circuit. ठीक है, good sir. We have calculated the equivalent resistance. So we know V is equals to I R equivalent. What is this? As I have said in the previous question, this is the most common problem which is asked in our competitive examinations as well as board examinations. Basically, this is known as Ohm's law. This is known as Ohm's law. So we can calculate given potential difference is 12 volt and the current flowing in the circuit is 0.25, whereas R equivalent can be written as R plus R equivalent. Giving you want to see if I could have done so much more than we have been, so much more than we can do. Nice quote. So we can establish this equation as R is equals to 12 upon 0.25 minus R equivalent. This means 1200 upon 25. Can 25 be cancelled with 1200? I guess no. Try to solve this, Kusuma. What will you get the value of 1200 by 25? I think it will be cut by 5. uh, Not directly by 25. So we can write it as 1200 by 25 minus R equivalent is given to as a 6. So I don't know whether it will be cut or not. Try to solve this question. है ना? Try to divide 1200 with 25. 25 4 ja 100, which is equals to 20, 200, or 25 8 ja 200. So yes, 1200 can be divided by 25 uh, with the factor of 48. So the capital R value is equals to 48 minus 6, which will be equals to 42 ohm. Very good, Kusuma. Very good. Actually, I'm not doing it by myself very much slowly. I'm doing it for you all guys so that you can understand the basic concept behind the question. And in the examination, you will be able to apply these concepts and calculate the answer as quickly as possible. I was just trying to uh, understand you the concept behind this question. Basically, what I have done, let us revise this if I could. Uh, Basically, we were given to calculate this value of capital R in this question, and we are given with the current flowing in the circuit, and we were given these three resistors. So what I have seen in this circuit is 10 ohm, 20 ohm, and 60 ohm resistors are connected parallelly to each other. So what I have applied it, so I have just applied the formula of parallel resistance equivalence in the circuit, which is equals to 1 upon R1 plus 1 upon R2 plus dot 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 1 upon Rn. Good, sir. Got it. Then after that, we can say that this whole R equivalent is in series with this small r. है ना? By applying Ohm's law, I have written that 12 is equals to 0.25 multiply R plus R equivalent. So from there, by putting the value or by substituting the value of R equivalent, potential difference in current, I have calculated the value of capital R. So this was how this question was to be conducted. Very good. Let us try to resolve question number 18. है ना? Try to do it yourself. Otherwise, I'm here to solve these type of questions. Tension not. I'm there for you all. So in question number 18, very much basic question. We are given with the potential difference this. It is just like the similar question as we have done the previous one. Just the similar one. The main difference is in the values of these resistances, nothing else. Or we can say that potential difference. Kusuma, can you give me the answer of this question, bacha? If you all have got this question, then try to resolve it. Uh, Try to calculate the R equivalent of this box, or we can say that R box. We can say that R box is equals to 1 upon R2 plus 1 upon R4 plus 1 upon R3. Yes, sir, why not? Yeah, surely. So 1 upon R box, as we know, these resistance R2 is equals to R3, which is 1 upon 50 plus 1 upon 50 plus 1 upon 75. So 1 upon of R box is equals to 1 upon 50. 1 upon 50, basically it will be equals to 1 upon 25 plus 1 upon 75. And the LCM would be 75. 3 plus 1, and R of box will be equals to 75 by 4 somewhere, I think. Yeah, 75 by 4 ohm. So I have got the resistance of this box. As we know, this box is in series with R1. Okay, na? Okay, Kusuma. I am just explaining the question. You can solve it, है ना? Somewhere else in your rough copy or anywhere. So try to send me the solution of this question or direct answer or option which could be the perfect one for this question. So we have calculated the value of R box, and now I will apply E is equals to IR equivalent. So I will be able to put the substitute the value of these. 6 is equals to current flowing into the circuit is given to us as current is not given to us in this question. Oh no, R1 is given to us. Oh, got it. Got it. So I need to calculate the equivalent resistance of the circuit. Oh, so there is no need to use this formula. This is just uh, a simple question as like the previous one. So we can resolve this question. Kusuma ji. Yeah, Kusuma got the right answer. R1 plus R box. Whereas value of R1 is equals to 100 plus 75 upon 4 somewhere. है ना? You can calculate this value roughly. If I calculate the value of 420, 4 cross 20 is equals to 80, 4 cross 19. Basically, it will goes 4 cross somewhere 19. है ना? I am cutting it roughly. So please don't feel है ना, bad about it or somewhere sad that, sir, why are you doing such a silly calculation? But I am just doing it for my help so that I don't have to repeat this question or exaggerate this question. Sir, can you understand Tamil? No, Aryan. I can understand only English and bacha Hindi. So you have got the question number of 15. Okay. So everyone try to solve the question number 19. If you could do this, then very much great. If you can't, no problem. Oh, sorry, I am writing poll. So you need to calculate the R equivalent in this circuit. So it is very much important question as for our competitive examinations. As you can see in the question number 19, as you can see in the question number 19, try to solve this question. So can I redraw this diagram like this? Come on. Yes, Kusuma. It is somewhere habitual for me to give poll to my lovely dear students. Okay, no issues. Kusuma, can I redraw this diagram like this one? 2, 2, 2, 2, 2. Okay. Again, can I redraw this diagram like this one? Yes, sir. Why not? So now we can see very much carefully that this 2 ohm and 2 ohm, they are in parallel. They are in parallel. This 2 ohm and this 2 ohm, they are also in parallel, sir. Yes, sir. No problem in this. They are also in parallel. So parallel, they both are in series. Okay, sir, got it. And the equivalent which you will get by solving the left hand side will be in parallel to the right hand side. So try to solve this question. So 2 and 2 parallel will give me 1, 1 and 2 and 2 1, and 1 and 1 and 2. This will give me again 2, and 2 and 2 are in parallel. This will give me 1 ohm answer. So answer will be A option. Yes, Kusumaji. Answer will be. So these were some interesting questions which I have tried to explain you, elaborate you. So we'll meet in the next class tomorrow. Hope for the best. Thank you so much, everybody.